Today we're going to finish talking about Newton's laws of motion, and we're going to talk about his third law. So let's just review the two laws we've talked about so far. So Newton's first law of motion dealt with inertia, the resistance to change in motion. So an object at rest wants to stay at rest, object in motion wants to stay in motion, and less acted upon by a net force. The second law was our equation, force equals mass times acceleration. So the second law helped us determine how force, mass, and acceleration are related to one another. So today we're going to talk about the third law of motion. And Newton's third law states that a force is always part of a mutual action with another force. So this means that our forces come in pairs. So there's an action, then there's a reaction. A force is a push or a pull. So there's an interaction between two different forces. So for example, when you push on the wall is going to push back on you. So you don't fall through the wall, so there has to be a force that's applied back to you. So forces come in pairs. Or if we're hitting a hammer, so there's an interaction that drives the nail in to the board, but the nail also pushes backwards on the hammer and causes it to stop. So there's an interaction between two forces. The force of the nail on the hammer, and then the hammer on the nail. So the hammer is going to exert that force on the nail. It drives it into the board. So there must also be a force that's exerted on the hammer to stop it, because it doesn't keep moving downwards. So Newton reasoned that while the hammer exerts a force on the nail must also exert a force on the hammer. So there's always an interaction between a pair of forces, one acting on the nail, the other one acting on the hammer. So if we were talking about equal and opposite forces, we would think they would cancel one another out. Okay, but they do not. This is because we have two objects and we have two forces. So one force acts on object 2, object 2 force acts on object 1. So they're acting on two different objects. So we have two different objects, two equal forces, not acting on the same object. If they were both acting on the same object, yes, they would cancel. Because one force is acting, let's say, on the person on the chair to keep him up, and the person pushing down on the chair. So one force acts on the chair, one force acts on the person. So how would Newton's third law explain a stick of dynamite? Does it contain a force? And the answer would be no. So a force is not something an object can have, like it has mass. So a force is an interaction between objects. So an object may possess the capability of exerting a force on another, but it cannot possess force. Force is not a thing or matter. In a later unit, we're going to talk about what the stick of dynamite possesses, and that's energy. So let's define Newton's third law then. So for every action, there is an equal and opposite reaction. So for every action, there's an equal and opposite reaction. So when we're saying action and reaction, we're talking about a pair of forces acting on two different objects. So if you hit the wall hits back on you, and that's why you can injure yourself. Because the same force that you apply to the wall applies that same force back onto you. So Newton's third law describes the relationship between forces. So we call one of those force an action force, and the other force we call the reaction force. So neither can exist without the other. So if we have an action, there has to be a reaction force. So they always come in pairs. They're going to be equal in strength. So if you hit the wall with a 2 Newton force, the wall pushes back on you with a 2 Newton force. And they're opposite directions. So if you push to the right on the wall pushes back left onto you. And they're going to occur at the same time. So they're simultaneously. Even though when we're describing it, we say for every action, there's an equal and opposite reaction. If you hit the wall hits you. It all happens at the same time. So for example, if you're running or walking, so you push against the floor, the floor pushes back up against you and propels you forward. Or if we're talking about the tires of your car, so the tires of the car interact with the road. So the tires push back on the road pushes then forwards on the tire, and you move forward. Or if you're swimming in the water, this is maybe the easiest one to feel. So you push backwards on the water, and the water is going to push forwards on you, and that's what drives you forward. So friction does come into play. And if we're talking about driving on ice or walking on ice, because of less friction, it's harder to apply a stronger force. So a person trying to walk on ice where friction is minimal, you may not be able to exert the same amount of force. And so it's harder for you to propel yourself forward. Thus, you have to take smaller steps or you walk a little bit slower. So without a stronger action force, the reaction force is also going to be less. And so it's resulting in us not moving forward as fast as we normally could. So another example here, when a girl jumps ashore from the boat, she pushes backwards on the boat as she leaps forward, and then the boat's going to propel her forward to the dock. So there's an action and a reaction. So dog wags the tail, and then you can also see his body actually gets moved as well. So the tail then pushes that same force back onto the dog. So you have some examples here. I want you to identify the action and reaction forces. So example 1, we'll do this one together. So the propulsion of a fish through the water. So the fish would push backwards on the water. The water is then going to push forwards on the fish. And he swims forward. So fish pushes backwards on the water pushes forwards on the fish. So the action, fish pushing backwards on the water. The reaction would be water pushing forwards on the fish. Example 2, a bird flying. So what's the action and reaction? So the action force would be the bird pushes downwards on the air with its wings, and then the air is going to push upwards on the bird, and thus it starts to fly. Okay, we have a foot and a football. So the foot pushes forwards on the ball, and the ball pushes backwards on the foot, and that's why you see the foot recoil, I guess you can call that. So foot pushes forwards on the football pushes backwards on the foot. Action, reaction. So here we have the earth and the moon. So the earth pulls inwards on the moon. The moon's going to pull outwards on the earth. That's why we can see this force of the moon on the earth in our tides coming in and out. So here we have the car driving and the road. So identify the action and reaction. So here the tires push backwards on the road. The road is going to push forwards on the car. Here we have an object coming down or falling to the earth. So the action and reaction are going to be between the object and the earth. So here the earth pulls downwards on the object. So we see it falling. But that object is also going to pull upwards on the earth. But why don't we see the earth move upwards? So we think about their masses. They're applying the same force. Force equals mass times acceleration. It's our equation. But the mass of the ball is very small. So that means our acceleration has to be large for the ball. And if we're applying the same force to the earth has to have a large mass. So that means acceleration is very small. So we see the ball move because it has a small mass, large acceleration. The earth we don't see move because it has such a large mass that its acceleration is very, very small. But the force